There is a stone circle in Egypt that is older than Stonehenge by 1,000 years. It sits in the Sahara Desert in a place called Nabta Playa, and it was built by people who left no writing, no cities, and no name for themselves in the historical record. What they left was this: a precise astronomical calendar, carved from megaliths, aligned to the summer solstice sunrise with an accuracy that modern surveyors have confirmed to within a fraction of a degree. These were nomadic cattle herders. They had no metal tools, they had no written mathematics, and they built something that told them with extraordinary precision exactly where they were in the year. Time, it turns out, is not a modern invention. The obsession with it is as old as the species. Before clocks, before calendars, before any of the mechanisms we now take for granted, human beings were tracking time with a sophistication that we consistently underestimate. Not because they were primitive, because they were paying attention to things we have completely stopped looking at. The sky was the first clock, and for most of human history, it was the only one that mattered. The earliest evidence of deliberate timekeeping is a bone found in Central Africa, the Ishango bone, dated to roughly 20,000 BC. It is covered in notch marks arranged in specific groupings that most researchers now believe correspond to lunar cycles. Whoever carved it was counting something. They were tracking a pattern in the sky and recording it on an object they could carry. This is the root of all timekeeping, not technology, attention. The recognition that the world moves in patterns, that those patterns repeat, and that knowing where you are in the pattern is the difference between surviving and not. The Egyptians understood this earlier and more systematically than almost anyone. By 3500 BC, they had divided the night sky into 36 groups of stars called decans. Each decan rose on the eastern horizon at 10-day intervals. By watching which decan was rising at any given moment, an Egyptian astronomer could tell the time of night with reasonable accuracy across every season of the year. They called it the star clock. It required no instruments, just eyes and memory and centuries of accumulated observation. But the Egyptians also built instruments. The shadow clock, one of the earliest physical timekeeping devices, appeared in Egypt around 1500 BC. It was a T-shaped bar that cast a shadow across a marked surface. In the morning, it was pointed east. At midday, you flipped it west. It divided the day into roughly equal segments that the Egyptians called hours. Not our hours, their hours were not fixed in length. They stretched in summer when the days were long and compressed in winter when the days were short. The concept of an hour as a constant unit of time did not exist yet. Time was not yet something you measured. It was something you experienced as a relationship between light and dark. The water clock changed that. The clepsydra, from the Greek for water thief, is one of the most elegant inventions in the history of measurement. A vessel with a small hole at the bottom, filled with water, draining at a consistent rate into a marked container below. As the water level dropped, you could read the time. The oldest surviving example is Egyptian, from around 1400 BC, found in the Temple of Karnak. It has markings for different months of the year, because the Egyptians had already noticed that you needed to adjust the calibration for seasonal variation. The Greeks and Romans refined it. The Chinese built elaborate versions with multiple chambers and mechanical figures that pointed to the hour. Some Islamic engineers of the medieval period constructed water clocks of such complexity that they functioned almost like mechanical computers, with automata that moved, bells that rang, and displays that showed not just the time, but the position of the sun and moon in the sky. All of this before a single gear had been cut. But the most precise timekeepers of the ancient world were not the Egyptians or the Greeks. They were the Babylonians. The Babylonians had been observing the sky from their ziggurats in Mesopotamia for centuries, and by around 700 BC, they had developed something that modern astronomers still use: the Saros cycle, a period of exactly 18 years, 11 days, and 8 hours after which eclipses repeat in almost identical patterns. The Babylonians had identified this cycle through pure observation. No telescopes, no mathematics beyond basic arithmetic. Just centuries of careful records, passed from one generation of priests to the next, until the pattern revealed itself. With the Saros cycle, a Babylonian astronomer could predict a solar eclipse years in advance. This was not magic. It was the result of what happens when a civilization pays close enough attention to the same thing for long enough. The pattern was always there. They simply watched until they could see it. The Maya did something similar, independently, on the other side of the planet. Their long-count calendar tracked time across cycles of 144,000 days. Their Venus tables predicted the appearance of Venus on the horizon within 2 hours over a 500-year period. Their observatory at Chichen Itza, El Caracol, has windows aligned to the northernmost and southernmost points of Venus's rising positions that occur on a cycle of 8 years. The building is a tracking instrument. The entire structure is a clock. What all of these systems share is something that gets lost when we frame ancient timekeeping as primitive. They were not approximations of what we do now. They were solutions to a completely different problem. We measure time to coordinate, to schedule, to synchronize across distances and time zones and global supply chains. Our timekeeping is about control, the reduction of uncertainty in a complex interconnected world. Ancient timekeeping was about alignment, about knowing where you stood in relation to the forces that governed your survival, when to plant, when to harvest, when the rains would come, when the river would flood, when the sun would return. The question was not what time is it. The question was where are we in the pattern and what does that mean for what we do next? The Roman calendar, before Julius Caesar reformed it in 46 BC, had drifted so far from the actual solar year that the calendar months no longer corresponded to the seasons they were named for. Harvest festivals were being held in what was functionally winter. The calendar had become a political document. Priests and senators manipulated it to extend terms of office or rush elections. Caesar's reform, which introduced the 365-day year with a leap day every 4 years, was not just an astronomical correction. It was an attempt to anchor public life back to the actual movement of the Earth. It was still off by 11 minutes per year. Those 11 minutes accumulated over 1,600 years into a drift of 10 days, which is why Pope Gregory XIII reformed the calendar again in 1582, and why the Gregorian calendar we use today required Catholic countries to simply delete 10 days from October that year. People went asleep on October 4th and woke up on October 15th. Time, it turned out, was harder to pin down than anyone had realized. The first mechanical clock appeared in Europe in the late 13th century. It had no face and no hands. It simply rang a bell at regular intervals to call monks to prayer. The word clock comes from the Latin clocca, bell. The earliest clocks were not about reading the time. They were about hearing it. We have been refining the instrument ever since. Atomic clocks now measure time to within 1 second per 300 million years. We have sliced the second into billionths. We have made time so precise and so ubiquitous that most people reading this have not looked at the sky to orient themselves in the day in years. The nomads at Nabta Playa built their stone circle because the summer solstice told them when the rains were coming. The rains determined whether they and their cattle survived. Knowing exactly where they were in the year was not an intellectual exercise. It was survival. We solved that problem so completely that we forgot we ever had it. The sky is still moving, the patterns are still there, we just stopped looking.